Hello again. We'll cover surface modeling in AutoCAD 2011 now for the next 2.5 hours with half an hour break. How many of you were not on my previous session today? Couple? Okay, so I'll not give anything for granted and just explain a couple of things again. My first session today on the power track was about parametric blocks, right, using surface modeling. So I explained a couple of things about surface modeling. I will explain that again. So the ones that were already there, just bear with me, and maybe it's again more clear. So the way of dividing the session today is before the break, we'll talk about splines, right, in AutoCAD, how we made them better, hopefully, this year, and about the basics of surface modeling with a couple of examples and explaining those concepts there about explicit surfaces, sensitivity, manipulation, and stuff. I'll make a small round of questions before the end of the first half, because and then do something similar at the very end. On the second half, we're going to be talking about parametric surfaces using expressions. Again, this is a little part of what we talked about in a whole class in the morning. And then we'll go into nerve surfaces and what's all about nerve surfaces and how we use them in AutoCAD. And then workflows between surfaces, solids, and meshes. As you may know, AutoCAD has the three topologies, right? Autodesk has many applications that have great mesh or great solids or good surfaces, but AutoCAD is pretty much the only one that has everything in one only package, which makes us a little powerful. And then interoperability with those 5 applications. Just to understand who am I talking to. Any Inventor users or people that know Inventor here? Couple? Revit? Okay. What about visualization? Showcase or Max? Okay, and probably nobody for Sketchbook Designer because it came up 2 weeks ago. But I'll also show it a little bit. So the whole point here is that I want to show you how to work with surfaces in AutoCAD, but also to see the big picture, which is, again, AutoCAD is not alone, right? You may be working with more than one application, or you may be working with people that work with other applications. So don't feel restricted by somebody using Inventor or Revit saying, oh, I need to move in that direction. If you're comfortable and what you do makes sense to be done in a generic application, that's fine. It's not a sin, right? But let's make sure we understand which are the workflows and how do we work between multiple applications in a workflow that doesn't lose information, there's data integrity on that. Okay, so I'll just go directly to the application itself. So I'm not a PowerPoint guy. Let's go directly to AutoCAD. And here we'll see a little bit what about the interface, the new stuff that we have on 2011, and basically just talk a little bit about curves, as we said. So on AutoCAD 2011, there's a new tab called Surface, right? There's also a new toolbar. I mean, we still make toolbars for new functionality. We are not killing that, right? I'm not showing AutoCAD Classic here, but there's a tool for that. So you may want to use whichever method you want. On the Surface toolbar, it's on the 3D modeling workspace, right? My 3D modeling workspace in particular is a little tweaked up. Maybe it's not the same that it goes out of the box. You will not see parametric panels tab on the 3D modeling workspace. You may need to put it there if you want to use parametric modeling for surfaces. I explained this today, but I'll do it again. If you basically type CUI, which is the command to get into the user interface, customization, right? And then you go into your current workspace. In this case, mine is 3D modeling. I can open ribbon tabs and see all the ribbon tabs I have. In this side of sight, I go to ribbon, tabs, and here I should just drag and drop parametric onto the other side, right? In my case, I already have it, so it doesn't make sense. So basically, again, just get this one here, and you should just drag and drop, right? Again, not useful for me because I already have it. There are a couple of other things here that you won't see unless you get those plugins. So I have something called Sketchbook Designer, which is a plugin for AutoCAD that's been available for about a year, and I'm having a class tomorrow about this, but I may show something. And I also have the plugin for point clouds, the one we did for Autodesk Labs. So right now we don't only open point clouds, but we can also do shape extraction on point clouds, so we can extract primitives from that. But I'm not talking about that today. But I just wanted to show you my AutoCAD, and then if you saw something not familiar, that's explaining why it is there. So going back to the Surface tab, our mission, I mean, I used to be until 2 months ago product manager for AutoCAD. Now I moved to another part of Autodesk. I'm managing the user experience for the whole portfolio. But when we were working on AutoCAD, the whole point was, how can we make modeling more powerful, right, within a generic application, right? I mean, in terms of how we build geometry in different applications in Autodesk, I could say we have domain-specific applications like Inventor, like Revit, right, like Civil 3D, even on top of AutoCAD, and applications which are generic, 3S Max, Maya, AutoCAD, right? We build, in the case of AutoCAD, we draw lines, points, arcs. We extrude those things, but there's nothing that tells a box it is a slab, right? It's just a box. Being a box may not be that bad, after all, sometimes, right? But for standard procedures, probably if you're making walls, probably a wall is better than a box. But if the wall starts not being your normal wall, like the whole town center here in Vegas, it gets a little tricky, right? So sometimes generic information is also good. So my point here is that if you're using AutoCAD with another application, another vertical application, could be Civil, again, could be Revit, could be Inventor, there are some operations which may still make sense to be done in AutoCAD, right? So conceptual design is one of them. Conceptual design requires a lot of flexibility, requires a lot of exploration, and that can be also taken afterwards into verticals or not, or you just continue doing stuff in AutoCAD and you document in the way that David showed in the previous session on the power track, or render, or whatever you want. So you can get with AutoCAD as far as you want, but some operations may be smarter and faster and more productive in other applications, right? So I'm going to show that too. Right? The world does not revolve around AutoCAD, but it doesn't revolve around Revit or Inventor or anybody else. It's just a mix of a lot of stuff that's happening. But back to AutoCAD. So the first thing we needed in order to create more powerful modeling was, especially with surfaces, was to have a good starting point. And curves, and especially splines, have been kind of overlooked by development in AutoCAD for the last 27 years, right? So last year was the first time, I guess, that we took seriously curves and splines and made something that makes a lot of sense, hopefully, again. I hope it makes sense for you guys. What I'm saying is that splines sucked before, right? You could use splines, yes, but if you were using splines in Alias Studio or Rhino or many other places, you'd say, okay, why can't I do these things here? So sometimes just that fact would get people out of the software because they need to start somewhere else. So now we have good splines. We are probably, of course, going to make them better, but this is a very good start. The first thing we had to do again then was to create a powerful set of features on curves. And if you remember, basically the spline command created splines through fit points, right? So we still have that option. It's called Spline Knot. And basically the Spline Knot lets you create a spline through a certain set of points, right? Remember what happened here when you wanted to finish a spline? You had to hit enter 3 times, right? First time for initial tangent, second time for end tangent, third time to really finish. At least in my experience, I'm putting my user hat for a second, 99.9% of the time I just wanted it to end. So it was 3 enters and just kind of destroying the keyboard. So why the hell don't they do this better? So the first thing I asked as a product manager was kind of putting, again, my user hat, just remove the nightmare from my life. Just first enter is finish a spline. So first enter, you're done. If you really want to go into tangency, you can edit the spline anytime you want. But removing 2 clicks in our 14, 15-hour-a-day schedule with the application, right? It's a lot, right? If you start removing 2 clicks or 3 clicks here and 2 clicks and 3 clicks there, you probably have 1 more hour to keep working, right? But it's in more meaningful stuff. So that seems minor, but it's not that minor. So I was saying that we had the option to create the spline through fit points. Fit points is one of the ways to define a spline. The fit points, again, are points in which the spline is going to go through those points. It may not be the only way to do it, and sometimes, especially if you're in industrial design, it may not be even the most suggested way to do it, right? So we also introduced the concept of a spline through control vertices. A spline through control vertices, I'll just take that out. Or let me just, I'll just take that out. A spline through control vertices, as you can see here, the point I am selecting is not the point through which the spline is passing. It's just the place where the tangent changes, right? So it's inflection. And at any time, if you select the spline, you can see that frame. Or, if you want, you do show CVs, and you can see it at all times. So depending, again, what you do, this method is much better than spline through fit points. I'm going to show a couple of examples. I'll try to see if that can be a little more graphic. None of them is better than the other one. That it makes sense depending on the case. If you know that your spline has to go through certain points, fit points is the way to do it, right? But spline through CVs is the best way to define a spline. Actually, if we were not getting into mathematics, because I cannot get into mathematics either, but the way a spline is interpolated through fit points is not as accurate as doing CVs, right? In any application, right? So as a suggestion, I kind of try to work more with CVs than anything else. If you see what's happening on, I think I have the command line off, so let me just go back to having the command line. As you can see, my AutoCAD is a little different. I mean, I always keep the command line undocked and transparent until I really need it. But when you start with spline, what's happening is it's the same command as usual, but it has 2 modes, right? When one is for CVs and one is for fit points. The mode is accessed once you go into the command. Why did we do that? Because if you have scripts, right, done at any time before March this year, in which there were no spline CVs or splines with fit points, if we had done something else or a new command, we would have broken each and every script that you have and getting more hate mails than ever, right? So the first thing that AutoCAD asks is, what is the method? And what we do is we create a macro inside the command that automatically goes into the right method. CVs for spline CV and fit points for Spline Knot. There are other questions when we start working. So for example, the degree. If we go here, for example, and I choose rebuild. Rebuild is a very powerful command that lets us work with surfaces and splines. So for example, I can go into rebuild and get a different amount of control vertices or a different degree. And the degree in a spline is, again, pretty important. By default, it's degree 3, which is kind of a standard. If you go into bigger degrees, you'll have the spline which is smoother. I'm going to show this with an example. I'm going to just draw some points on the screen. And I'm going to make them more visible, right? So now I'm going to start the spline CV and the degree. Normally when I get into, I mean, as usual, right? Long right click, because I have the, that's set to get the right click menu, right? Degree, let's start with 3, which is the default. and I'll go through this point, this point, this point, this, this, and this. Right. I go back to the same command, but now the degree is going to be 5. Okay, I didn't do it. Degree 5. And see what happens. The spline is smoother, right? What's happening is that the bigger the degree, the bigger the distance with the control vertice, and the smoother the spline. If you go into software for automotive design or something like that, when they really need smooth surfaces, which is something they normally do, right? They use bigger degrees. And if we go into degree 1, you're basically forcing the spline to go through those points. So it's just like, could look like a polyline. But it's a nice polyline because it's a polyline that it's actually a spline, so it has a couple of benefits, right? For example, it can move in space. No polyline can ever move in space, right? XY plane. Let's keep working on this. What else can I do with a spline? Let me just go back to the degree 3, which is the default. Another thing we did is add what we call in-canvas manipulation, right? So how did you edit a spline in the past? Right? Spline edit, got a set of obscure options, and see if you can figure out how to do with that, right? I mean, no reason nobody used splines, right? It was kind of really great. So in this case, I'm going to show you what we can do now. If we have the spline selected and we just hover over any of the vertices, right? Not clicking, just hovering, we'll get options. For example, stretch the vertex, which is the most obvious one, just move it. But for example, add vertex. So if I click add vertex, I'll be able to create a new control vertice. I can also come here and say remove vertex. So that'll be removed. And this, for example, I realize that I really don't want this either because I want something like this. And I need more detail on this part. So I go and say refine vertices, which creates 2 control vertices but keeps the shape of the curve. Right? So, and now I can go here and say, okay, I want to move this point and do whatever I want. So the other interesting thing is how we control the gizmo, right? Last year, when we did 2010, when we did mesh modeling, we had that controller for a while, but we made it a little better, right? More powerful. And now, pretty much, I would say that I pretty much not rotating or moving anything with commands and doing everything with direct manipulation with this guy. So, for example, I can just hover over the z-axis, and now I know I'm just moving along that axis or moving on this plane. Right? So as you can see, it's very simple and fast to make any tweakings on this spline. And here's a trick that you may or may not know. Let me go to 4 views, right? And sometimes you may need to do that. I mean, you may want to have a top view, a left view, and a couple of perspective views, right? So I don't know if you knew. Maybe you did, and I'm being just stupid, but you tell me. You can start working on this viewport, and then just by clicking once on another viewport, you can continue the command on this other one or wherever else you need to do it. Right? So you have that kind of control. Sometimes having one single viewport doesn't help that much. If you know any other software, any other surface modeler around, could be Rhino, could be the Alias, any of those. Normally, by default, they have more than one viewport because it's very hard when you get into these kind of things. Right? If you make a box extruded, you can see it from the top, it's fine. When you go into this kind of shapes, top view is just part of the information, but not everything. So you may want to go back and forth on this kind of visualizations, and it's good to know that you can go from one viewpoint to the other very easily. Okay, I'll just go back to single here. So here's my spline. As I said, we can make any kind of editing on it on top of it. The other interesting thing is that we can also change between control vertices and fit points. So if for any reason you already made your spline with control vertices, but now you want a specific point to be somewhere else, you say show fit points, and then you can move fit points along the curve. The other important thing here is that you can, and probably that is not very, can you see like a little cross on this first point? If you don't, just believe me, there's a pink cross there. It's the beginning of the spline, right? And the beginning of the spline is very important for some operations. For example, if you're adding a fit point or a control vertex, that will be added after the one you are creating. So if it's after, you need to know where this whole thing started. And the other thing is, when you're working with splines and with certain commands, you may find that certain commands need to understand which is the first point. For example, let me do something. I hope this one works. It's going to be a little challenging. Something like this. I just made a rectangle somewhere, right? And I'll try to sweep this guy through the spline. There you go. Right? So it did the sweep. Some commands like sweep have options like scale along the path. For example, let's say I say that this has to be 3. Oh, in this case, it doesn't allow me because it may be generating an error. The same with this one. But let me just do a circle, which is going to be simple for this. Okay, and grab this guy. See, there you go. You see, the spline is scaling. I mean, the sweep is scaling along the spline. So for scaling, you need a first point and a last point. So let's say that you built this spline a week ago, or somebody else did it, and you just got the sketch, right? How did you know which was the first point? Again, go to Spline Edit, see the vertex, have a little cross. I mean, just lousy little cross here. It was not easy to do it, right? Again, no wonder why nobody used splines. So now we're making it much easier, right? The other thing is, as you see now, I try to select the spline, but of course there's a sweep and a spline, and I get this new dialog box here. This is called selection cycling. Selection cycling can be toggled on and off from the status bar from here. My suggestion is selection cycling is good because it lets you select stuff that's kind of, I mean, how many times even in a 2D drawing you had to select something and you had a hatch, 2 lines and something else, right? And I know you can circle, right, between all those things, but it's not very visual. Here it's very simple. You either want the sweep or the spline, and I want the spline. Fine, I got it, right? So it's very fast. And watch this. I mean, even if I can be adding a new vertex, and even adding a new vertex still keeps moving this whole sweep and everything else. That's because we have associativity, which is something we're going to be talking about later. What else can you do with a spline? If you go to Spline Edit, or just click on the spline and go to this option, right? For example, we can also add what we call a kink, right? So if you see, I'm tracking a cross, right, on the spline, and I just add this little point here. This point A kink is a point where the continuity is lost, right? Normally the spline will have always C2 continuity all across the spline, but we now managed to create a point of lack of continuity within the spline. Depending what you do, this may be very, very, very useful, right? So, and there was no way to do that before. So, again, many things, many small things that we added to the splines. So we mentioned that we had Spline CV and also Spline Knots. There's something else called Spline Freehand. So how many of you remember the command sketch? How many of you like the command sketch? I don't want to see. Yeah, do you like it? Why? Is some sense of masochism or something? Really? Good. Well, that's always somebody. So what happens with sketch? When you're doing the sketch, AutoCAD is recording every point where you're going through, and then it creates a set of tiny little lines from each point to the other, right? Well, maybe that could be useful sometimes, but now, check it out. If I do Spline Freehand, let me go first to top view. I really want to do this from the top. And there you go. Just kill these guys. And Spline Freehand, I remember pen up, pen down, all that stuff. Crap, nothing. So now, we just do the stroke. I mean, I've always kept my mouse clicked, the left button. I finish the stroke. I can do another stroke. I can do another stroke. And when I hit enter, I get splines. So now this is a spline. And this is not 27,351 points, right? So how can you control that? This is the whole thing. Spline Freehand, it's still the same good and old sketch command. So if somebody really, really likes sketch, like our friend here, you can still use the points, but maybe now you want to use this thing. Sorry. So we can do lines, polyline, and spline. So we can convert all that into a polyline, a spline, or a line. By default, it's in spline because we assume that this is better for this. And it has two options called increment and tolerance. The increment is a distance which, when you make the stroke, right? Let's say this is a building, right? And that stroke is the whole base of a convention center here, and it's, I don't know, 300 meters, half a mile, whatever this stupid distance is here, right? So if you do that, probably you don't want 1 point recorder after every meter or something like that. You want something every 20 meters, 30 meters, 40 meters, right? So then you would insert 40 before starting. So the increment is the distance in which AutoCAD is recording points. And then the tolerance is the distance between the point and the spline. Just like with the controversy and the degree, right? So the closer to 0, the closer AutoCAD will have to go through those points. So if you have a serious problem of pulse, right, when you do the sketch and you put tolerance close to 0, the spline will look like crap, right? I don't know how many, do anybody of you use tablets like a Wacom or something like that for work? 1, 2, yeah, Ramesh for sure. 3, 4, 5. I would have loved to bring my Cintiq, and then I realized after I brought it, and I brought a lot of stuff to show with a Cintiq, I realized that I only have one output from this computer, so I could not. But normally I would do this with a stylus, right? I am an architect. I learned to sketch by hand. I still try to sketch by hand as much as I can because the gesture of the hand is something that no mouse can catch, right? And it's great to be able to do that sketching and then say, okay, I want this to become a spline. Because what I want to do now with these 3 guys that I just made, maybe I just want to trim them. Sorry. I just want to trim them. And, I don't know, make an extrusion and patch this thing. I don't know where it is, but it's that. And give G1 continuity, or G2 maybe, which is even better, right, to this thing. So from a sketch into this, which again I don't know where it is, but sure somebody in Vegas will build it. You can do it very fast, right? So another trick when doing Spline Freehand is once you do the spline and you click enter, you will have a certain set of control vertices, right? In this case, it was a very small set of control vertices, but I'll go really far away and do another spline. And in this case, you see that it's more like a bumpy, right? Because based on the distance that now I had, because I zoomed really out, my increment was terrible, right? So if I grab this spline, yeah, how can I edit this thing? Right? It's starting to look like the old sketch command, right? That nobody could edit. So now, new trick. Remember I talked about rebuild? Just let's click on rebuild. And this guy has 266 control vertices. And probably I don't need those many. So what if I try and say, okay, what happens if I use just 24 and make a preview? And I see both my original spline and the new spline. Is that okay? That's enough? Maybe not. So I do escape, so I get back into the dialog box and say maybe 32, preview. And that's starting to look like what I may want, right? So once I go back to the dialog box, I see something called maximum deviation here, which says 22. In this case, it's 22 units. Could be anything, 22 inches, feet, whatever you're using as a unit. But let me go back to the preview. And at some point, somewhere, you'll see this icon, right? It's two circles with a red line, which is hardly seen there. But what that means is that is the place of the maximum deviation. That is the place in which the original spline and the new spline are the farthest apart, right? So it's just telling you this is how much, I mean, where's the place of the biggest difference between both things you're doing? And maybe you don't care. Right? Again, if it's conceptual, maybe at that stage you really don't care about 2 inches or 3 inches or 1 meter. Right? So if you just click enter, you'll get the new spline, and the new spline is much more manageable. It has 32 control vertices. Right? So doing a rough sketch and doing this on top of it, it's very, very fast, it's very easy, and it leads to a better handling of the whole thing. Right? Because modeling, especially surface modeling, is all about control. Right? Are we good with splines? Am I going too fast or something? Just please tell me. I know I tend to speed up. And I speak Spanish as a native language, so I have some accent. So just let me know if I'm not clear, please. But once we have good splines, again, so the basics for having a good surface is having a good origin, right? So now that we have good splines, and of course we have, as usual, the same polylines and lines and arcs as usual, let's start building on top of that. And basically what we have now is a set of surface types on the creation panel. Some of them are already known. We had Loft for a while. We had Suite for a while, Revolve. We now have tool clips. And something like planar surface or network surface or blends, patch, offset. This first set of 6 surfaces are surfaces that you create from scratch, from curves, or from, in the case of the planar, you can just draw it. The other surfaces, like blends, patch, and offset, need a surface as an origin, right? So you're not going to use those until you have something. So, for example, a patch is just closing gaps between surfaces, so you need a surface to close first. So let's start with something. Let's make something easier for a second. Something like this, whatever. And let's start with a revolve. I showed something like this today, right? So I'll just create an axis. And you see, you get manipulation. I mean, you get instant feedback on the screen. You can say, okay, this is 120 degrees, whatever. You could also have, I'm going to do it again. You can also define the direction, so you can reverse it because you need it on the other direction. And once you finish, if you click it back, there's an icon here, there's a control here, which lets you still edit the surface. And if you click on the spline that created the surface, if you change the spline, you'll be still changing the surface. Even if you add a vertex, you'll still be maintaining the surface. That is because we have something called surface associativity. And surface associativity is a feature that relies on something we built for 2010 for parametric drawing called the associative framework, right? It's an engine that keeps all the relationships between stuff inside AutoCAD, right? So in this case, the surface is changing because the surface remembers it was done by a spline, and if the spline changes, the surface will try to update to the new position, right? And that happens not only because of surface associativity, but because the surface remembers that it is a revolution, right? And that is what we call explicit surface, right? So if I click on the surface and I go to properties, the surface is surface revolve, right? It remembers it's a revolution, right? So how many of you are familiar with the concept of nerve surfaces? Some, okay, a little bit. So a nerve surface is basically, at the end of the day, this is a nerve surface, right? But it has a wrapper on top that tells them, okay, you are a revolution. So you just remember where you came from, right? And just honor that origin, right? If you're just a nerve surface, the nerve surface is only edited based on the grid of U's and V's on both directions, right? So a nerve surface is amazingly powerful when you want to edit kind of singularities within this. For example, if you want an extra bump somewhere on the surface, that cannot be described by a revolution, right? But if what I want is to change something on the surface that will affect the whole revolution, then doing that with a nerve surface is a little tricky. So by default, what we have available is the explicit surface. Here there's another toggle called nerves creation. If you hit this toggle while you create the object, you will create a nerve surface from scratch. But then, if you click on that surface will not remember it is a revolution. So if you really wanted to change the angle, you need to go back and undo or whatever, right? So suggestion from here, I've been modeling a while with these things, just keep explicit surfaces as much as you can. If you really hit a place in which you need to make extra changes that are not within the creation process of that entity, yeah, do whatever you want, go to nerves. But in the meantime, keeping explicit surfaces allows you to have a lot of flexibility. For example, let's go to another method. Let me just mirror this guy for a second. Right? And I will create a blend between this edge, enter, and this edge. I'm clicking enter between both selections because blend needs sets of curves for the operation. So you could have done a blend with 3 curves on this side and 3 curves on the other side. So that's why you hit enter in the middle. So once I do this, okay, I got the blend, and now I can define the continuity. Let's say I want G2. I will explain this in a second. And that's quite a complex one. Yeah, in this case, it's too complex. I'll just keep it where it is. So I'll just go again and just keep the G1. Great. So I have this guy, right? So how much time would you have spent in AutoCAD to do something like this? I still don't know what it is, but it looks great, right? But check this out. This guy knows and remembers it's a blend, so it keeps information, for example, about continuity. It keeps information basically about continuity and a couple more things. But my point here is that if that will always be just a surface that will be defined by its relationships with the edges of 2 adjacent surfaces, you don't need to convert that into nerves. Because once you do that, you lose all associativity. Done, died, kaput, finito. right? So that's another thing. Other surface methods, for example, offset. I can grab a surface. Let's say that you want to have a second surface at a certain distance, right? The first thing offset will do is, because offset in 2D is very simple. You are either on this side or on the other side of a 2D space. In 3D, it's getting a little more complex. So where are you going? Where are you clicking? Right? When you click on the space in AutoCAD, what are you really clicking at? The 0, which may be anywhere else, right? So in this case, AutoCAD is telling you, okay, offset is going in that direction. But of course, you can flip it. And you can even do it to both sides at the same time, if you want. And just for the sake of clarity, we'll do it just to the outside. And then I'll define a distance, like as usual. It can be input, numerical input if you're very accurate, or just any distance. And here you go. You made a second surface, which is an offset. But again, this is an offset, so the offset remembers it's an offset and now allows me to change the distance. So imagine this. This is the shell for a very, again, complex roof somewhere, again, in Vegas or somewhere that they like this, Los Angeles, right? Place where they like nice and funky and strange and expensive architecture. So once you have this, imagine that you also made you made a blend between this edge and this edge. No, you didn't do this one. Let's go to this one probably. No, it's doing whatever here. So whatever you do on the surfaces, it will keep the relationships. You can do it on both directions. You do whatever you want here. You could start from there and then, for example, make an extension of this surface. Something like this, for example. So there's, again, a lot of power on, yes, surface modeling.
Is there any kind of maximum or minimums on your offsets?
No, so the offset will depend on what you're doing. For example, in the case of this surface, right? That's a great question, actually, because I'm going to show it on this one. So in this case, for example, right, the offset will create another surface that goes like this, right? At a certain point, if the distance is too big, it will self-intersect. At that stage, probably AutoCAD will tell you, you know what, I may pass and not let you do this.
That's the forming constraint?
Yeah. Basically, it's lack of mathematical ability to define one entity that does what you want. Which, at the end of the day, I kind of like that, because if you cannot describe it like this, I'm not sure you will be able to build it anyways. Right? At the end of the day, we build stuff, right? Either in manufacturing, architecture, we don't pay it for nice pictures. Somebody at the end of the day pays us for producing an object, right? So whatever we do here can be magical and fantastic. If it doesn't end up in something that can be built and reproduced, we are just artists, which is not bad, but the money is on the other side. So again, all these are explicit surfaces, are surfaces that remember their origin. And as you see, you can create all levels of associativity between them. Let me just do something very simple. I'll just start from another. Let me just go back to a specific file. Yeah, this one is fine. Let's say I'm designing a watch, right? A wristwatch. And normally, people that use surface modeling have at least an idea of where they want to start from. So they want to start from a set of curves. So in this case, I already defined a set of splines, right? So what I'll do now is, for example, I will create a network surface between these two, which is one direction, and enter then these three, which are the second direction. So I get this, right? Fine. It's starting to look nice. Now, what I want to do. So maybe I now want to extrude this other one because I want to use this for trimming. So I want to trim this surface against this surface, and I want to remove this part and this part. And now I want to trim the inverse. I want to trim this surface against this guy. And I want to take all this. It's starting to look like something, right? Now I'll do something similar here. I will extrude this, and I will trim these two surfaces against this one. So I'll remove this extra material, and now I'll trim this against these two ones, and take out this. Starting to look like something. Now I may want to mirror this whole thing and get probably the end point here so we can be a little accurate. Right now it's time to think, because if you're mirroring and you're not taking the splines, it may take a while for AutoCAD to understand what you wanted to do. Should not take that much, but I have other things open, so it may be taking some bit of memory. But it's going to do it. I don't know why it's taking that long. But you see, I mean, just think how you would have described this in 3D modeling in AutoCAD before. It would have been a while, right? So, and the nice thing about this, while it keeps doing something which is, of course, not predictable right now, I have betas here, so it may be screwing my computer a little bit. If I change any of those lines, which were the first things I did, the whole structure will change. So if somebody says, okay, you know what, why can't we make this side, right, this side more curvier? So we just need to add maybe a control vertex on that spline, right? And the trimming will also change. Everything will change based on that. So normally, that operation in most applications that even do surface modeling will imply undo, 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 and undo, and a lot of undos, and a lot of frustration and hate and stuff, right? And again, the whole point, I don't know what's happening here, and the whole point about design in general, and I hope you agree with me, it's exploration. Never the first thing you come up with is the final, right? Either because there's somebody else making decisions and opinions, and they normally want to change everything, right? Which is kind of happening a lot, right? Or just because, as a designer, you never feel satisfied with what you do, right? You may be at the end of a process, but you still hate what's happening there, and you still want to make it better. So if you don't have a tool that allows you to make those decisions and change things without having to do everything again, believe me, you will just get the first thing that you'd made will be the one that you'll use just because you're lazy and you don't want to do it 20 times. But if you have an option, right, that allows you to be a little faster with those things, then everything changes a little bit. I think I'm going to kill this. Yeah, there's something happening in the background for some reason. Okay, there you go. So as I said, right, if anything changes in this thing, you see what happens? The whole structure changed. So this is now when you're going to get a little cocky and say, okay, what do you want me to change? Right? And or maybe just tell your boss, okay, it will take me a couple of days. You'll do it in a second, and then you do something else, like working more on other things, right? So this is all about that idea of the explicit surfaces, the fact that all of these guys here remember that they came from an extrusion, revolution, or whatever option, right? So if this was a curve, you could have done other things, but not these. So it's important for you to understand when to use which. Other things you can do, let me just kill this. And let's say that I start with an arc. And I'll copy this thing up. And I'll just make this a little bigger, and probably this guy a little bigger too. And I'll do one more. I'm trying to do some kind of bottle or something like that. So now I'll use a loft. So I'll select each of these guys, right? And I get some questions, which in this case they're not very relevant for this. And remember, you can select any of these and keep checking what you want. For example, I want it more like this. Now, I want to mirror this. No, this is too far away, so I'll do it probably from the top view, which is a little smarter. No, maybe not. I'm getting some trouble here, probably because some betas or anything. So my point here is that you can keep changing and adding or taking detail as much as you want, right? In a very simple way. I'll do the mirror, yes. I'll do the mirror here. This is not becoming a bottle at this point, but I don't care that much. I want, for example, to make a blend between this edge and this edge. So blend, patch, and offset, blend and patch basically happen between edges. So here I want really G2 curvature. G2 curvature means that it's really smooth, right? When you have G0, basically you have just two surface edges which are adjacent. Nothing else than that. When you have G1, you have tangency between both. When you have G2, you have the equal radius at both sides, which means that if you cast some light on that edge, right, you will not see anything, right? And that happens, for example, a lot in industrial design, right? Many times in a car, for example, you are joining two pieces, but you really not want to see any kind of discontinuity there. So how can you check that out? So we introduced analysis, a little bit of analysis, so nobody from Inventor freaks out. So the analysis we introduced is just the main things that you may need to know in order to understand if this has good continuity or not. For example, in this case, I'm using what we call zebra analysis. Has anybody seen something like this? Zebra? What happens with zebra analysis is those stripes, right? When they go from one surface into the other with continuity on the stripe, that means that there's good continuity between the surfaces. When it gets disrupted, it means that there's a problem. And this is much more visual than anything else you can do, right? So, for example, if I go back to the blend and I change this into G0, see what happens? There is obviously a lack of continuity. So the lines don't go from one to the other. If I go back into G2, you see what happens? The continuity is there. So this is a very visual way that it's probably used by anybody doing surface modeling around, right? So we have a couple more, like draft angle. Draft angle is the one that lets you understand if you make a mold of that, you will be able to take it out, right? We are not going into the kind of analysis that you would expect to have in something like Inventor, or you would expect to have in something like Moldflow or Algor. It's AutoCAD. At the end of the day, we are doing design and not fabrication, right? But at least when you are designing, there are a certain level of questions that you need to answer, which are based on these things. Is this good continuity or not? Okay, just check it out. And then at any point, you can go to these options here and say, okay, clear zebra analysis, and take it away, and that's it. So as you can see, and I can still go to the original arc and make some operations here. And you see what happens? The whole thing updates. Probably if my operation is very, very kind of extreme, something will break. I'm not saying that anything breaks, nothing breaks anytime, but you really have to torture the surface a little bit to get something broken. Let's close on the other side. I'll go back to a gentler thing here. This is too much. Okay. And let's close this on the other side. Blend this edge against this one. There we go. I'll keep G2 and G2. And I'll make a patch on the top, so I select the 4 edges. And by default, it's G0, but I want to try, for example, G2, so I want continuity here. But I really don't need continuity down here, so when I do the patch, I'll just grab these 4 friends here, and it will it will stay G0. So we have something here, could be prettier, but it's still more powerful than anything else probably you have done with AutoCAD in the past in terms of this kind of shapes. Okay, so the arc is on the other side, I guess, yes. And you can still go back to the original geometry and try to do some things. So what happens if I make this arc a little taller? Probably something will break, but let's check it out. It didn't, right? There you go. So some operations, it's very interesting. Yes. Yes, and that's where I'm going. Yes, yes, sir. This was not scripted, right? I don't know him, really. So now I can use a command called Sculpt, and Sculpt will get any, well, not any, but most of, like, enclosures of space, right? Convert that into a solid. So anything that AutoCAD believes to understand is watertight, right? And it closes space, that will become a solid. Sometimes it can get tricky. In D2 continuity, sometimes it feels like it's fine, but it may not be exactly fine after some tweakings. At those times it may fail, but normally this will create a solid. That's it. Right? It's already just a solid, and then you can work with it. So yes, and that was my whole point for the second part of the class, in which I talk about the workflows between surfaces and solids and mesh, because the same happened with mesh. You may remember or not that we did mesh modeling last year, and we introduced subdivision surfaces, which is a very powerful yet a little imprecise way of working, right? But it's great for somebody that's kind of starting. And because let's make it clear, not everybody knows at the very beginning of the process how things will look like. So if you really wanted to do something like this, right, I would challenge anybody on this room to tell me which curves will create this thing. I don't know. I don't know, really. So sometimes, if you really know where you're starting from, precision surfaces are amazing. If you don't know and just sculpting, maybe mesh modeling is great. The good thing about mesh modeling, so the bad thing about mesh modeling is that it's not precise, because you see smoothness, but actually it's interpolating between planar faces, right? So what you see as a curve is probably a set of facets, right? So for construction, that is not great, right? But for rendering, I know Toy Story, which is when all this started, right? And you could not render a cylinder. You had to render, I mean, the least amount of faces, the better, right? Then it's better to have this kind of definitions in which it looks like a curve, but it is not. You had a question? Yeah. No, yeah, and that's the other trick. Once you leave the surface modeling, associativity will be lost. Yeah. So that is still something that some people that are sitting to your left may want to hear if you need more. We have AutoCAD PM there, Diane. So she's monitoring if I'm saying the right things. No? Hey, Diane. So. And I convert this into a solid or a surface. For example, I will say I want to convert this into, I'll copy the guy here. And I can convert this into a solid. And now this is a 3 solid. Or I can convert this into a set of surfaces. And now that this is a set of surfaces, I can use surface modeling features. And now this is really a good representation of a surface, because this has continuity. And the other didn't. I'm not saying the other one is bad. I'm just saying the other one is great to just start sketching stuff, but this one is amazing to build things, or to be able to get things into fabrication. So a couple of examples that I wanted to show, and I'll continue with this on the next part. So being 2:30, let's I think it's a great place to make the break. We have half an hour break for some reason. If you want to come before that, that's fine. If not, we'll see again at 3. If there are any questions or anything, you may ask something now or after the break. After the break, we'll talk about more features. Here, nerve surfaces, and I'll go into some examples, right? So you can see this in action and tell me what you think. Okay? So let's make the break now and come back at 3. There's a lot to do, so let's do it. Couple more things before I dive into a couple of examples. I mentioned the difference between an explicit surface and a nerve surface. So when would I use a nerve surface? Basically when the explicit surface and the method of creation doesn't describe the kind of change I want to do on the surface. For example, a bump somewhere, just a little thing, right? In those cases, remember, nerve surfaces are not associative, so whatever you do there, you lost all the history before that, or at least on that part, right? If the rest of the structure is still explicit, the relationship between those are fine, but not with what's done with nerve surfaces. And basically, that's all. So I'll work on a surface and create a nerves from that. So let's go back to the example of the revolution right now. Okay, and this is what I have, right? So as I told you, if the change that you need to do is a change that can be described by the surface, the revolution like this is the best method you will ever get to make that change. That said, if what you want is, for example, something here, and not here and here, which is what revolution would do, then you will convert to a nerve surface. When you convert to a nerve surface, it looks like nothing happens, because again, as I told you, the explicit surface is a nerve surface with a wrapper on top of it that says, okay, you are a revolution, right? But when you go and show CVs, remember that the spline had that kind of frame of contour vertices that you could see. The nerve surface has the same thing on both directions, on what we call U's and V's, right? Direction U, direction V. So now, when I go into rebuilding this thing, right? I get, remember that I had 1 contour vertex count and 1 degree. Now I have degrees on both sides for both directions. And it may happen to me that I need more detail on a specific side. For example, I want to keep 5 on the U and 12 on the V. So I make the preview, right? And I have now more detail on this direction than the other one, which may make sense depending on what you want to do. You may want to get more detail on one of the sides. And you still have the surface deviation, which in this case should be close to 0. Yeah, it's very small. I'm using big values, so this is very small. So now, let's do some more here. Let's put, I don't know, 24 by 10. Okay, so this is what we call the hull, right? The hull is that kind of extra frame of contour vertices on both directions. And now, what can we do with the hull? So we can do whatever we want. That's the whole point, and that's the nice thing about nerves. So I could select specific points of the hull, and if you want to select more than one, you just go with Shift, and all the points that you selected will get hot, the grips, right? And then, for example, you just want to move these guys up, right? So this is the kind of thing that you could never have done on a revolution, because we cannot describe this part with a revolution, right? Or you could have maybe needed to expand these 6 here on this direction for some reason, right? So everything still has continuity, G2 continuity internally, it's fine, but you get this kind of behavior. What else can you do? Let's say that you want to add some detail here. And by here, I mean between existing contour vertices. Two options. Just increase amount of contour vertices for the whole thing, which may not be very smart because you're increasing information in places which you don't need that, or add some detail here. So we have two options called add CVs and, well, of course, and remove CVs, but in this case I want to add CVs, in which I select the surface, right? And AutoCAD lets me track across the surface. In this case, if I want to add a row of contour vertices on this direction, or I can also right-click and say in direction, so in this case it's inverted. But of course I don't want more in this direction because I already have a lot. But I do want more on this one. So I may want to add another row here, right? If I had wanted to have something like this before, I should have gone from 10 contour vertices to 20. And 20 by 24 contour vertices, I mean, it's information. At the end of the day, you're just adding meaningless data on your model and just noise, right? So don't do that, or at least don't do that. Yeah, don't do that. Or try that at home if you want, but it's at your own risk. And you can, of course, then be a little more granular on those little changes that you may need to do to your surface. But there's even one more method, which is yes? No. Do you use Max? Okay. Yeah, you mean that when you are controlling the area of influence depending on the amount of contour vertices, but you are not. I asked you about Max because Max has an option called soft selection that when you select any node, any vertex, wherever, you may also select the entourage of that point and define how the adjacent points react to that operation. And that is pretty much something very normal in mesh modeling, but not here. So the way you would define the influence is just basically by the way that you define the contour vertices. But there's no way to say, okay, if I move this one, this and this will move. So if these two are not moving, and you move this one, what will happen is, if the curvature gets bigger here, it will do like this on the other one, just like with any curve. Yes. You can do that. I didn't talk about the weight yet, but yes, you can define the weight on those changes, especially when you're in explicit ones. I'll go back to that. That's a great question because I forgot to talk about the weight. The weight. Another thing, when you go into CV edit bar, then I was saying that when you now I added more detail on one direction because I needed more granularity on a certain spot, on a certain parts, right? But I can go to kind of the ultimate way to do that, which is track any point of the spline of the surface, right? And I really want it here. So once I click on this position, the gizmo appears exactly on that place, and what I can do at that moment is either just directly move the points wherever I want. There's something interesting here. Whenever you work with something like a box or something very predictable, it's very simple for you to understand which is the direction up, right? But what is the normal to this surface? I don't know, right? So if you right-click on the gizmo, there's an option, Align Gizmo With, and if you say Align Gizmo With Object, then you will make sure that the z-axis of the gizmo is really pointing exactly normal to the surface as it is today. So that's an interesting one. And then you could also define. You could also play with the bulge, with the weight, right? In this case, I am working the influence of that area with the weight of the spline. You see what happens? That I am moving my cursor and the bulge here, which is the way it gets into that point, it's changing, right? And I could have done that with pretty much any operation. For example, if I go back to creating something simple again, like a couple of arcs. Oh, sorry. I'm making this smaller and just making a loft between these guys and mirror this little far away like this, and I'll make a blend between these two, and I'll make it G2, for example. So when I go to back to the surface, if I see the properties, I have the continuity here, but I also have something called the bulge magnitude. So this can get bigger, and probably here it's not too obvious. I'll go to X-ray and do just a little thing here. I'll create a patch on top of this, but first I need to close it, and I'll do a patch between these four, and I'll make this G2. But I also change the bulge, and the bulge by default is 0.5, and I go into 1, for example. See what happens? So this is still G2 in all the points, but now the weight it changes the weight of the spline, how the surface gets into the other surface. So that is something that some people may want to tweak, right? It's a little strange here how the shape, but you can go back and change this as many times as you want. Again, because it's an explicit surface, so you can go here and say, okay, no, actually I need 0.2, which is almost like nothing. If I get closer, I'll see that. I still have the oh, sorry, it's not going anywhere here. I still have the G2 continuity here, but as soon as it leaves the surface, it's already concerning, right? If you go here and say, okay, I need it at 0.5, right? The area of influence is getting a little further away. So we have a way to define the bulge. I normally don't find many options or reasons in which I really want to change that, but absolutely it's something you can do. A couple more things that I didn't talk about. For example, trimming. I did some trimmings on the first example, but I can also trim against line work. For example, let's say that I use sketching like the Spline Freehand, and I create these 4 splines. I'm going to rebuild them a little bit so I get less controversies, like, I don't know, like something like 8. I'm going to do this for each of them. This is not a batch operation, of course, because there's no way that probably that you want to do this in like batch. And I'm going to trim these parts here and make a network surface between these two, enter these two. And now let's say this is a roof, right? But let's make it a little nicer. So we want to start just tweaking the edges. And in the middle of this, there's going to be a building, right? Emerging from that roof. Again, big scale, inspired by Vegas. Everything is huge here, so let's do something like that. Let's make a circle, and the circle will be in the middle of this. And let's trim this surface with this circle. And as soon as I click enter, what I get is the projection of the circle on the surface, so I can decide if I want to keep this part of this part. Obviously, I want to remove this part, so I click here. And there I go. I have the hole. And this is a place, this may sound trivial, but most surface modelers at this time, they lose the history. And we keep it. So this means that if you make this bigger, you see how the whole thing is updating, right? If you move it, it will update. I mean, you got to be very nasty and very bad to the geometry in order to make it corrupt. But obviously it happens, but it doesn't happen that much. Again, we're assuming some level of common sense on the operations, right? So you can do that as many times as you want. If you want to untrim this, either you select untrim because you still want to keep the geometry there, or you basically delete the circle, and of course, since there's no circle, there's no trim because everything is associative. So depending, if you want to keep the circle for another thing, just do untrim, and if you don't care about the circle, just remove it and you're done. Yes. So again? Yes. Well, not that much with this. No, not that much with this because, no, actually it's kind of it's reevaluating everything on the fly. You get a bigger file if you do solid history, because solid history is keeping all the solids somewhere, right? I mean, when you have a box and you remove a part of a box, you actually have 3 now, but some of them are hidden. It's tricky, but it's a good thing to know. I mean, if you get a solid model which is kind of big, if you do a VREP and remove everything, probably your solid model is 5, 6, 10 times smaller after that. So again, you need to know if you want to keep or not the history. In this case, it's always reevaluating, so it may get a little bigger, but it's not that you have 20 surfaces there, right? It's doing everything on the fly. Yeah. It altered the surface area. I mean, as a property, you say. Let's go back to this. So I mean, you mean about the area of the whole thing? I mean, let me see one thing. Yeah, right. Yeah, and that's what I'm trying to do. It's here. Yeah, but I don't see the area anyways. It's somewhere. It's not in the properties. It's strange. Yeah, but yeah, I thought it was here. Yeah, that's strange. Another thing could be interesting to know is you can also project stuff on the surface. For example, let's say that you have a spline. There you go, and you need that spline along the surface, right? So in this case, you'll project the UCS. Select the curve. Sorry, you select the curve and then select the surface, and something's happening. There it is. Right. So now I have this spline here, which is basically going through the surface. So you may need that for an extrusion. You may need that for a path, for a sweep, for example, on something that's a structure on top of another surface, something like that. And this was pretty much difficult. Not impossible, because nothing is impossible. It just required 2 days of workarounds, right? And now it's pretty simple. So you can project in 2 ways: to UCS, which is my preferred method, or to view. And again, normally most surface modelers project to view, so they do kind of the normal to the view at that point. You can do both. And if what you're projecting is a closed surface, you can also have auto trim that already also trims the whole thing. I will normally trim with this one because this is associative and this is not. But this is, again, something interesting to keep in mind. Let's go to an example. So we've talked a lot about stuff here, but how do we create, or what will be the steps to create something? So I have a data set here that kind of tells a story. So in this case, let's say that it's coming here. Let's say that there's a company that's manufacturing that shaver, right? It's not me. I mean, they're doing that in Alias, Inventor, whoever, I don't care, right? But I have a small shop that's still using AutoCAD, and I customize cases for these things, right? I'm asked to create an enclosure, right? A case for a box for this shaver. So what I'm going to do now is see how to start from scratch. I already kind of made some points, so I'm not doing everything from scratch, but I'll try to go from the beginning into a kind of a finished result. So this is, again, X-ray view to me is one of the most interesting things that we added as a visual style ultimately. And I already have a set of points in a couple of hidden layers. So in this case, I'm going to open this, and I'll just add something so I can see the points, right? So I'm going to start building some spline CVs through these points. What I did when I created this from scratch was I just went into the side view and said, okay, this is the place in which I want those points, and then I just captured that so I could make it faster here. It didn't make sense for me to stay for a while just kind of designing, because I would take more time than I want, and we don't have that much. So I'll get this side too, right? And just by doing this, I was just sketching with Spline Freehand and converted it to the other one, and that's fine. Back to this one. In this case, again, Spline CV. Good? No, not good. Okay, again. That was because my command line appeared and distracted the snap. Okay, there we go. And let's go for the last one. This data set is available for you, so with the whole steps. So feel free to replicate it. Okay, so I have my set of splines. There you go. So now I'll make a mirror of these two using probably an endpoint here and going into ortho mode, so I get this. Probably may also want to make a mirror of the shaver, so I can then catch any kind of interferences. For the time being, I can also isolate it. Do you know that in the last version, actually as a subscription advantage pack for the previous one, we have an option that we can basically right-click, isolate, hide object. So you're not turning the layer off, you're hiding the object. So you don't need to make sure that you're in a layer in which there's nothing else. You just hide whatever is in any layer, and you don't spend time organizing the drawing in a different way. So that's what I got here. So I'll start with a loft along these three sides. That will be the beginning of my modeling. And for the other part, I'll just do a network surface because I may need some extra detail at some points. I'll show you why. But in this case, I'm going to use a spline through fit points because I really want the spline to go through this point. Right? If I had chosen CV, it would have gone somewhere close to the point, but not through that point. And I can do another one here. Right? And the nice thing about the network surface, it would also allow me to, because I could have done this with a loft using two guides, but if I had wanted another spline to define another level of detail at some point here, for example, then the network surface is better. I'll just do it right now as it is. So I will use network surface between these two, which is one direction, enter, and then the other direction. So I got my network surface. And I'm starting to get a shape that I can understand, right? So what happens now is I may I want to do the side. Probably this is going to be plastic, I mean opaque. This is going to be transparent, and then I just want the sides. And the sides could have been or could be continuous or not. Let's try continuous first. So I'll do a loft, and I'll do the loft between. In this case, I could do it between the surface edge on this side. And why the surface edge? Because I need the continuity. So I click Control and click on the surface edge, so I am grabbing the edge of the surface, right? Normally, if you just click on the surface at any place without controlling the keyboard, you will just select the surface. But if you select with Control, you are accessing the sub-object level, right? So if you select Control on a solid, you will select either faces, edges, or vertices. If you use Control on a surface in the edge, you will select the edge of the surface. For the second one, I don't care, because I may select the surface edge if I want, but anyways I'll give you that G0, because what I want now is that this side has G0, which is position, it's just getting there and nothing else, but I want G2 curvature on this side. I could even try and see how good or bad it is right now with zero analysis. And you can see that it's kind of very abrupt, but still the stripe goes on. It passes by. You see, it just passes by. If I go here and click on position and get that in G0, this is really not continuous. I mean, and not being continuous is not bad or good. It's just a design decision. Do you want the surface to be smooth between in the intersection between both, right? Or in transition, or do you want that to be an edge, right? Depending on what you want, the good thing about the analysis is that it lets you understand what you're doing. So I'll just leave that as G0 in both sides. I'll go and do it here too. 0 and 0, fine. And now we'll make a patch at the end, and a patch at the other end. Yeah?
When you went back to that loft edge, why didn't you use a blend, or couldn't you use a blend instead of loft?
I could have. I mean, actually, most of the, a loft and a blend are not that different. I mean, the blend is creating a third surface that has a certain continuity with two other surfaces. But the blend can only exist when you have a surface edge to attach to, right? The loft could have been done with either lines or surfaces. So there's no rule of thumb there. It's just depending on what you want to do. For example, if you want a blend, the blend will always go one continuity on this side into the other continuity on this side. The loft doesn't care that much about that. I mean, you can do that, but for example, you can also add a guide. You may want to say, I don't care about, I want to do G0, but I also want, if this is my one surface and this is the other, I want to do a bump like this. You will never get that with a blend. So it's kind of different ways to get to the same place. If you understand why, I mean, for example, the same thing. Why would you use a network surface as opposed to a loft with two guides if you're talking about just four edges? No reason why. Unless you have a third or fourth guide in the middle, and the loft cannot make a loft with many guides, just on the ends. Am I clear? Fine? Okay. So that's why you have multiple methods. One thing I didn't mention, I was forgetting about that. There are some commands here that are a little tricky and gave us a hard time, and I think it was better. Was better one last year when we got hate from customers and we changed the sysbar. Yeah, that's why being in a beta is good, because then you can give us opinions. Let's say you have a rectangle and you extrude it. What would you expect to get? A surface or a solid? Because if I have a non-closed profile, if I extrude, it's always a surface. But if it's a closed profile, it could be both of them, right? So what we did, at the beginning we made a sysbar, so when you make extrusion, you had to decide with a mode if it was a surface or a solid. What we did finally was, actually, we have the mode still, but if you call extrude from the surface tab, you will create a surface. If you call extrude from the solid tab and the profile is closed, it will create a solid, right? It's kind of a macro. When you go into extrusion, it will say, okay, where am I? So solid tab, mode, solid, and it will do it, right? So those are commands we call ambiguous because they could be doing two different things depending where you are, right? And basically that happens to extrusions, revolutions, sweeps, and probably lofts, right? If they are coming from a closed profile and planar profile. The other interesting thing is that since we did this for surfaces, now we can make surfaces between non-planar profiles. In the past, I mean, in 2007, we introduced Loft, right? There are many operations that could not be done with non-planar profiles. An extrusion could not start with a non-planar profile. Now we can do it. So it's much more flexible in general. Yes? Yeah. So that's it. I mean, if you extrude a rectangle from the surface tab, it's just the sides. If you extrude it from the solid tab and it's really closed, it's a box. So you just may want to be a little careful where you call the command from. Or, I mean, in the past when I wanted something like that, I mean, the past before that, I would normally create the box as a solid because it was the only thing I could do, and then explode it and remove the top and the bottom. So again, 3 more steps or 4 more steps. If you make those 3 more steps over the 14, 15 hours a day that you work when the days you're lazy, normally you work 20 hours, right? Then at that time, it's a lot of time lost on stuff that should not be happening, right? So we have this here. What we may want to do, I mean, we may want to do a lot of stuff on this object. In this case, we could, for example, give thickness, right? Create a shell out of this. So we can create a shell in many ways. For example, we can go into offset and define a solid and define a distance and create the solid. Or you could just directly go into the solid tab and use thicken and create the solid. So this is now a solid object, right? Now, I could also make a solid with everything here by using Sculpt, right? So this is a solid model now. And why would I like this to be a solid model? Well, because I may want to shell it. I may want to move this into fabrication from AutoCAD or make, for example, or start making some documentation, right? So we could go, and some of you may have been in David Kahn's class about flatten this. So you may have seen this, but you can create a section plane, for example, right? And the section plane can allow you, for example, to create, I don't know, a live section, or create the 2D geometry from that and start some documentation if that's what you need. So depending on what you want, you'll do more documentation here. But the other thing you can do is, I will go on and open I'll open Inventor, right? Because I'm a firm believer that every tool has a sweet spot and has places where you can do it, but it's not the right, I mean, it's not the right place, it's just not the most efficient place. So, yes.
If the surface is watertight, can we do Boolean operation on it?
Yes, yes. I mean, you can, I mean, why would you do a Boolean operation on the surface? Yeah, but you can also do trim. I mean, Boolean operations in a surface can be done, but there will not be a associativity there. So maybe what you may want to do is, let's say that you have 2 surfaces and you are subtracting, you want to subtract kind of a cylinder from those, right? I may just draw a circle, trim both surfaces, and create a blend with G0 on both sides. So I get the same result, but I get associativity. It all depends on what you want to do at the end of the day. Again, I believe that if you have the right tools, right, and you know how to use them wisely, you have power. So there are many options there to work with. So I'm opening Inventor, which takes some time. Yes, we've been there. I will open Revit, which also takes some time. But again, it's important for me to at least convey the message that if you heard a lot about digital prototyping here at AU or in any marketing material from manufacturing, AutoCAD is part of the digital prototyping process as a front end for conceptual design, right? It is not the crazy uncle, right? It is part of the whole thing. So here, I can do many things. I can directly open the DWG file, and that is a little trick in Inventor because by default it opens 2D, right? But there's an option to import DWG within Open that will give you the solid, or you can import an SAT file. In this case, I already did it, just to not lose too much time, because we only have half an hour left. So this is my shaver complete with materials. This is what I brought into Inventor. And in AutoCAD, I previously divided this, the solid into the whole surface into two solids. So going back to AutoCAD for a second, right? Before making the solid, I created a network surface in the middle of this because I knew that one part was going to be the plastic part, which was the bottom and the two sides and the patches with the surface on top of that. And the other surface would be the cover, which would be some kind of transparent plastic, right? So I wanted to take those two parts already separate into Inventor. And that's what I did, but again, it doesn't make sense to do it now, but it's just creating a network surface here in the middle. Once you go into Inventor, wherever it is, here it is, right? This is what I get, one part, and then the other part, visibility on. This is the guy here, right? And here I have both parts of the object. I don't see the end of sketch for some reason. Okay. There you go. So then I could make a shell. I will subtract this part first. I will just remove visibility here. Okay. And here, no, that's fine. Right? I made a shell, so I don't know if you can see that this is now void, right? And then I created a couple of work planes in order to create a rib, right? So that rib, I can do it in AutoCAD. Of course I can do it in AutoCAD. I will just get the surface, make a projection like we learned. So I get a spline on the surface, then I'll get a spline on top of that. I make a loft between both and make a thicken. I thicken that. Inventor has something called rib that makes ribs, right? So if you just draw a line where you want the rib, Inventor will calculate exactly what's the size of that and how to top it. In AutoCAD, you will be doing operations and operations and operations and operations to get that. Okay, can you do it? Yes. Does it make sense? Probably not if you have a digital prototyping application like Inventor next to it. So I can do that again with the other rib, right? And then, of course, I need to cut it to get the shaver. So this would be kind of a Boolean in Inventor too, but it's simple. And then after that, I could, well, let's go back to the whole assembly and visualize everything. Right, so this shaver is ready to be, at least to start the process of manufacturing, because, for example, what I need now is to get the edge of that, for example, and create a lip. And again, there are tools for that, right? So, which I'm not finding now, but it's somewhere out there. So I could meter, I could make a lip on that. I could go into the tooling, and this is not an Inventor class anyways, right? I could go into the tooling applications and then create a mold for that thing, right? And again, this is not the sweet spot of AutoCAD, right? But getting to those shapes in Inventor would have taken some more time, right? So why not take advantage of the best potential of both things? Again, screwdriver for screwing things, hammer for other things. You may use the same one for both, yes, but something will be very, very damaged on one of the cases. And the same thing if let's leave Inventor for a second, and let's go into my very good friend Revit architecture. And of course, we don't do shavers in Revit, so let's work for a second on remember when I made that big roof, right? I'll do something similar. I'll start from here. So I just made a little mesh as a tower that I will convert to a faceted surface, solid, sorry. And this was kind of the beginning of, if you remember AutoCAD 2010's image on the box, this is the beginning of one of the towers, and then I made the other one on the roof. That's a picture that you have seen hundreds of times already, everywhere. So in this case, I could go back to, again, Spline Freehand, based on the fact that I know exactly what I'm doing now, because I see the end result, I'll do the rebuilding of these things. Yeah, it is fine. You see how I'm removing details. I will also create, I'll trim the ends so I can create a more precise network surface. Network surface can also be done without removing the trimmings, but it will interpolate the whole thing. And now I want this to be a little up here. So I'm taking not only the surface but also the splines, right? Because if I only take the surface, for example, if I do this, AutoCAD will tell me you're about to lose continuity because the surface will be detached from the curves. Do you want to do this? Of course I don't. Cancel the operation, right? So in this case, again, I go to the splines. I do a couple of nasty things to the whole structure. Not many. I don't want to, again, waste too much time on details. But just to make it look a little different here, I will now create a planar surface at the bottom. And I will project, what I want to do now, I want to do the sides, the walls, right? So I want to project the curves of the roof onto a planar surface so I can now create the sides. And this would have taken a lot of time before. So in this case, I'm going to select the curves, and the curves are actually the splines here, right? So I select all the splines that I used. Hit enter, and then select the surface. And here I have the projection. So with the projection there, I can also already trim this surface against these splines and see how selection cycling is really helpful because it lets me select exactly what I want. In this case, I will remove the exterior. So I just get this. And now I can use, for example, Loft between this side and this side. I'll keep everything like ruled, D0. Because many curves in architecture make it a little expensive to build. So I'll just make everything G0 and ruled. Last one. And fine. You see all these controls. This is about direct manipulation. It's the whole concept that how many dialog boxes did you see in the 2 hours? Just rebuild. Dialog boxes, they're not bad, they're not evil, right? It's not the new enemy, but it takes time because you have to preview, apply, right? This keeps you focused on the building. Now I'm going to just do let's say a circle here because I want to trim the roof against this circle. I can see what I'm doing right now, right? Just for the sake of fun, I'll just do another circle down here. This is what I call fun. I mean, as nerds. It's going to be slightly asymmetrical. And I'm going to basically trim this guy here against this circle. And while I do this, I'm going to start opening Revit. And I'll blend this and these. Sorry. I'll blend it with Revit. This and this. It's coming. And probably I want this side to be G0 because it's when it meets the end here. And I want this side to be G2 because maybe my roof continues down that wall with the same material and I want continuity there. So I get this. Again, how much time would you take to build something like this before, even in Revit? A bit, right? So why spend time when you can do it faster? So, and the nice thing about this, again, let me just keep iterating on the same idea, is that if you grab this spline and you just say, okay, what happens if it's a little bigger? It changes, right? How many of you are architects? One, two? No, not many, right? I mean, when 2 or 3 architects meet and start talking about something, there may be something like 20 ideas, right? So this is something that you really want to have is the flexibility to make those changes very fast. So once I have this, I may want to convert this into a solid. Why? Because if I convert this into a solid, Revit can read the mass. And if it reads the mass, it can create slices for the floors. Right? This is the whole point here. Revit can understand the surface, but if there's no mass inside, it will not be able to cut a floor. It will just be able to create walls. So I'll be opening Revit. Yeah, try. 2 days left. Guess I need to activate it. New file, just a second. This is very fast. I mean, I'm not going to make the whole building. It's just, I'm just making you understand how to get it in. So what I'm going to do is work on the massing environment, which is where I would normally do conceptual design in Revit. But in this case, the massing environment will just bring the stuff already done in AutoCAD. So I will go into massing site. I will do an in-place mass, which is a mass done here, and I will insert CAD link. So I'm not importing, I'm linking the AutoCAD file. There it is. There you go. Why don't I have it there? Interesting. Shade towers. I'll just import the base now. I will tell him that this is meters, and I want this origin to origin. Right? Because I want to keep the origin from AutoCAD. Because if I import many things and I keep the origin, then everything will come into place. Revit by default will try to put everything on the center. So everything will be on the center regardless where it was in AutoCAD. And that kind of sucks, right? So you just do it by origin here, and Revit is basically opening the AutoCAD file that it's not the one I did because I didn't save it. You saw that, so I got tricky, but I just had one already done, so there was no issues there. There you go, but it's pretty similar, right? There you go. So I finished the mass, and let's go to the 3 view. And what I can do here now is, for example, create walls, right? But I'm going to create wall by face. So I will define, for example, that the location of the wall is, what I'm touching is the interior, for example. And now, when I just click on this, I'm creating walls. You cannot see them there, but let's do shaded with edges, and you'll start seeing something. There you go. And for example, I can also create a roof. Roof, here it is, by face. Or I could eventually just see if I can tap here and yeah, let's just do the roof. There you go. Create roof. You see it? And now comes the magic. Let's do elevation. And in the elevation, you see here is there was already an elevation put here, so I'll just put it a little further up here. There it is. And now what I'm going to do is grab the mass. I think I moved the roof, but it doesn't matter. Grab the mass, and I do mass floors. So I will intersect the whole thing with level 2, which is the one I want to slice. Okay. I'm getting the slice there, which I already got it. And now I will create a floor from this slice. And I will take the mass. I will just change the visibility of the mass. A second. Oh, it's already off. Right. So remove the mass. So there you go. I mean, what you see here is what I get. I mean, I didn't finish everything, of course, but I have my floor, I have my roof, I have some of the walls. I can come here and, for example, say, annotate, for example, no, that's fine. I could create, for example, a schedule of this, so I can get the area of this floor. And based on any changes here, because I decide that this is too big or too small, I can go back to AutoCAD, change the surface, resculpt, resave, and update here. So you are not losing data. And normally, my experience, unless it's a very small shop, the designer and the guy that does the final details is a different guy, right? One is more prone to the details and knowing everything about the construction, and the other one is more the artist. So that's fine. They can speak together. They can work together. And the last thing before I get some questions, hopefully, is I just want a sneak peek of Sketchbook Designer, which is the new thing that we just made. The nice thing about Sketchbook Designer is it allows you to be very flexible with just sketching. So let's say that, and there's again an example on the handout. Let's say I'm gonna. Yes, Alias Sketch is the old name. When they decide to rebrand it, and everything, iPad, all that is called Sketchbook now. I'm just going to open Sketchbook Designer, and I'm going to show you a couple of things you can do there. If you're interested, there's a class I'm doing tomorrow about Sketchbook Designer, which is much longer, because I'm talking about compositing and doing a lot of stuff, but I just want to talk about surfaces here, right, because it's about surface modeling, this class. So this is my Sketchbook Designer, which works both for Mac and PC. Oh, by the way, like AutoCAD, right? And I can do vector sketching. So if I'm in a vector layer and I make just a stroke like this is a spline, right? And again, imagine this done with a tablet and a stylus, which is the nice place to do this, right? So you may want to do something like this. You also have control, just like kind of in AutoCAD, to change a little bit the shapes here. You can go and select the whole spline, because this is actually a spline. Select the whole spline and try to see how you want. For example, I want this like that. You can also trim the ends, just like in AutoCAD, right? You can, for example, use transforms. I kind of love this. And this looks like a bitmap, right? But it's actually not a bitmap. So when you end up doing all the transformations, there you go. You can now export curves into DWG. I'll just call it test. This is AutoCAD 2010. Okay. AutoCAD, open. Test. Curves. Splines. For some reason, I know the reason, but it goes into paper space, right? Because Alias Sketch or Sketchbook Designer needs a scalar environment, and model space, of course, is not scalar, right? I mean, it has sizes, proportions, but it's not scalar. It's not in a specific unit, right? So it has to go into paper space. But anyways, you can just grab here, just do cut and paste or whatever you want, and take this into model space. You can rescale here if you need to, right? Yeah, but it will scale according to a page, right? And so that's why it brings that to paper space, because paper space is the only place in AutoCAD in which you have predictability of size, because you already set up your page to be, I don't know, A4, B2, or whatever, ISO, whatever, right? So that's the only thing predictable in AutoCAD. What if you go into model space, it could be meters, centimeters, Armstrongs. Did somebody ever work with Armstrongs? But it's there, right? Let's just change this. I'm going to change into white so you can see what I did. And this is what I would normally have done in a napkin sketch, right? On the other side. So you have here the flexibility of a napkin sketch, and even more because I don't recall being able to do this on a napkin, right? Probably very drunk, but not okay, something like this. And of course, you can also make it look nice and go here and, for example, paint, because I really want this to be something that looks approximately like this, with this kind of shiny thing there, and do whatever you want here, or just sketch on a paint layer. And then your pencil becomes a real stroke, a raster image. And you can take all that into AutoCAD. So once you're in AutoCAD, the good thing is that this became a set of surfaces that could have been extruded. Well, this is a small extrusion, but you can see what I did, right? So again, I only talked about Sketchbook, Inventor, and Revit. I could have talked about Showcase or Max. While I kind of make the conclusion, I'll just open a file in Showcase so you can see a little bit the kind of stuff that we can do. I hope to have one already there. So questions before I kind of start to wrap up? No? It was overwhelming amount of information. Yeah.
When you make those real complicated surfaces, is there a way to unroll them into a developed surface?
Yeah, I got that question before. No, you can't in AutoCAD. You should be able to do that. I mean, for example, if it's sheet metal, you could do an Inventor. There's a plugin for Rhino that is supposed to already be there for AutoCAD, the Teraflat. Yeah. Isn't that one?
I can't remember what I've done it.
Yeah, right. So, yes. So the answer is there are ways to do it if you have the right plugins, as usual. Okay, so let me see if I have something in my recent scenes. Okay. Somebody was yesterday on Tron when we showed Tron on yes? No? Yeah. One. You may have seen this. We showed this speaker, right? Actually, I made this in AutoCAD. I made this in AutoCAD last Saturday at 2 a.m. because the senior VP wanted this speaker in AutoCAD, Showcase, Max, and everything else. It took me create all that shape in AutoCAD and take it to Showcase and make the videos that you saw on the presentation. All that work was 2 hours from 2 a.m. to 4 a.m. from Saturday to Sunday. I'm not saying I'm happy to do that, but I'm saying that it's very fast, right? So you saw the video in AutoCAD, so I don't even have to bring it up, but I may. Right? So what is this? It's a set of surfaces, right? Well, this is solid now, right? But it's basically two curves. I think I'm not sure I got the initial from this. Not sure I have it, but basically I grabbed the sketches from Area Sketch. I got the sides, right? So I created the base. So from the back of this became one surface, right? There was a loft between three sections and two guides here and here. Then I made a patch that basically closed this. I made a circle in front of it. I just extruded it back, and I made and trimmed it and made a fillet between both surfaces. Done. Looks complex. I hope it looks nice, but basically it's and of course that taken into Showcase and where you can apply and change materials and do stuff like the one I did on the presentation, right? Well, this is the viewer. I don't have the license here because it's connected to a server and I don't have access from here. But I could change colors, I could change environments, illumination, whatever here. And this is a nice way to make a presentation for a customer, for your principal or whoever, right? Your family when they die. So what do you do at work? This, right? So this can be used by pretty much anyone, and it's part of the design suite, and it's a great application. So I just imported the file from AutoCAD, and it catches the materials in AutoCAD. So if you apply materials in AutoCAD, they are there already. If not, you can just apply materials here, or you want to change the materials, you can do it here. So my whole point here is just try to understand, and this is the great thing about EU, right? Try to understand where are the best points or the strongest points of each application, right? And see how that kind of relates to your workflow. And if you need something like this to make a better presentation, or something like Inventor to go to fabrication, or Revit to create a building information model, that's fine. I mean, you don't have to do everything in AutoCAD. But don't go to the other extreme, which is, oh, now I do BIM, so AutoCAD is a piece of crap. Because at the end of the day, you need the crazy angle a couple of times, right? So whenever you need flexibility, AutoCAD is great. Whenever you need documentation, AutoCAD is absolutely unbeatable, right? So, and the good news is that it communicates well with the other applications. So I wanted to make this as the best class as possible for solid surface modeling, but I just wanted to finish with that idea of whatever you do in AutoCAD, I mean, just make sure that you're doing the right things in the right place, right? And don't be scared to try other things and to move to other applications, as long as they are from Autodesk, of course. And well, because at least we ensure that things work correctly between them, or at least the best we can. So, other questions, or yes?
When is your class tomorrow?
You may need to check it out on the. Yeah, I can go fast. I mean, just don't look at my email. My class tomorrow is this one. It's at 11, but I'm not sure. I mean, I'll probably go tomorrow and ask for the room. It's from 11 to 12. So, okay. Any other questions? No, this is real time. This is real time on screen visualization rendering. I mean, it's for anything you think. I mean, it's. I mean, if you put a big building here, it may suffer a little bit because there may be many nodes. But I've tried with buildings and it works. Okay. So okay. Thanks a lot, everybody. And the power track has finished.